You're listening to the Skeptics Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptics Guide to the Universe. Today is Wednesday, January 31st, 2024, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santamaria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, everyone.
You know, whenever I say the year when I'm introing the show, it gives me such like a time whiplash. You know what I mean? Like, we've been doing this for so long. And we started out saying in 2005. Now it's like we're in the future. It's 2024.
Yes.
It's crazy.
I feel so old.
It wasn't that long ago. I think we've talked about this recently. The 2000s were just not that long ago, but in a way they were that long ago.
Yeah.
There are all these memes that stress me out on like Instagram and stuff where it'll be like, if you recognize any of this, it's time to get a colonoscopy.
Wow, that's awesome.
Oh, yeah, it's all just like stuff I grew up with, you know. I'm like, oh no.
Yeah, when you can tie it to a fad or a device or a fashion or something, I don't know. It leaves an indelible mark sort of in your mind, and then you're moving away from that constantly, and you just realize, oh my God, I'm so far away from that.
Yeah, because it doesn't seem that long ago when you anchor it to something like, I think the last one I saw was like lip smackers, which is like the chapstick that we all use, the different flavored ones, caboodles, see-through phones. And Limited 2, which was like a store that all people my age shopped in when they were young.
Oh my God.
Yeah, the limited, yeah.
But this
Limited 2 is for kids, yeah.
Yeah.
Like, oh no.
I always tie SGU, I think, as far as products go, to iPhone, because we came out before the first iPhone.
Just before,
Wow.
pretty much, yeah.
That's nuts.
That's not a bad way to do it.
Yeah, that a seminal piece of technology like that. Yeah, that's a good way to measure it and a good way to feel old.
Do you think that was the most disruptive piece of technology in our lifetime?
What?
The iPhone. The smartphone.
Maybe.
For
arguably.
individuals, maybe, yeah.
It's up there, man.
It's hard to point to like a single thing.
But just, but there is our life before smartphones and after smartphones.
Sure.
I wouldn't say smartphones. I'd say the internet.
I'd say the internet in your pocket.
That
For
too.
me, you mean the web? For me, the web, like 92, around that time, early
but
90s, web is definitely a huge demarcation.
Yeah.
It is, but I also think that our lifestyles changed more because early in the web, I don't think we had really figured out how to use it. Like, it was still kind of novel, and there were like different things. Like we were in that era that you always talk about, Steve, where like when there's a new technology, we try to figure out how to just replicate old technology with new technology.
Yeah.
So I think about like going onto MapQuest and printing the driving directions and then still putting them on paper in the car. Whereas once you had a smartphone in your pocket and you could actually afford to be on the internet, because most of us couldn't at the beginning.
True.
And you could just navigate where you were going, that was game changing.
Yeah,
I think
agree.
For a lot of people.
Oh, yeah, it was huge. Absolutely.
The change in lifestyle was more abrupt and I think more profound with the smartphone. The internet, it was the World Wide Web, was more of a slow burn. And you're right, it didn't really change how we were doing things, just gave us sort of another resource. Eventually it did, but it took a long time.
Took a while, yeah. Because at first it was slow, it was expensive, it was clunky, it wasn't very user-friendly, all that kind of stuff.
Yeah, that's a really good example, too, like printing directions off map.
Yeah.
Versus, versus
we all
just
did it.
having GPS in your phone.
There was an intermediary there, Garmin, and those devices were the step bridging the two devices, a cellular phone and what ultimately became a smartphone with your...
Were those technically online? I know they were using GPS, but did they relay through the internet? They had to, right?
Not necessarily.
I don't think so.
No, you had a Garmin device. It was
I had a Garmin device. Or like a TomTom.
That was talking, of course, but that had to be talking to the satellites.
I know it was talking to the satellites, but was the way that the sort of map continuously updating, did that use any intermediary? Like, did it go through the internet? I guess not, because you were paying for a subscription.
You need Wi-Fi, right? But then you'd be driving and hopping from
and cars didn't have Wi-Fi back then.
Yeah.
I think you would have to
straight to the satellite.
You would have to update it deliberately. Like, it wasn't just like auto update connected.
Wi-Fi.
Yeah.
Oh, right.
Well, some of the cars that had it integrated, you had to like have a CD with the maps on the CD.
Correct.
Yeah.
Yeah, almost you had to
Right.
install it.
Yeah, remember installing software from CDs?
Yeah. Oh, yeah.
Oh, yeah.
my
How about
God.
floppies, dude?
Oh,
Yeah.
here we go. Yeah. Oh, boy.
Do you remember saving those for a long time, even after you never needed them before? Like, once drivers and software was online, there was that weird intermediate period where we're like, well, we can't get rid of the OS, the CD of the OS.
Filing cabinet full of backup CDs. Yeah.
Exactly.
Now I don't care.
I still tease Steve a little bit when you told me you got your first jazz drive.
That was cool, the jazz
They
drive.
they were big, man. I mean, that was huge.
It was huge, and at the same time, it wasn't huge.
20.
Right?
Yeah, I never had one of those. I don't remember that at all.
And how long was it really a thing? Maybe a year or two? It was almost like a bridge device to
It was.
So the jazz drive was
Yeah.
like the laser disc of
Yeah.
in a way.
computer drive. Okay. Yeah. Like, just didn't really ever fully catch
There's also,
on.
Evan, a zip drive. Remember the zip drive?
Sure.
Yeah.
Oh,
Zip
our
drive.
zip drives were big.
Yeah,
I still have my files. I still have my
You
zip,
do?
yeah.
No.
Oh my gosh.
Just in case I can read them someday because I hate to have stuff on there. I don't even know what's on there.
I only recently threw out the last of my, what were they, 3.5-inch floppies?
What?
Or the 3.25? What were they?
Yeah.
3.5? The those hard shell
the
discs.
hard ones, yeah.
We called
Yeah.
them diskettes.
Diskettes.
Yeah, the little ones where you would slide the metal piece to be able to overwrite them.
Yeah, with what 1.4 megs of information you could store on there. Or something?
1.44.
Yeah. Oh, 1.44.
Oh, yeah. That's the thing I mentioned the other day where I saw a video on like Instagram or TikTok or something where the guy showed his kid a diskette and the kid was like, oh, you 3D printed the save icon.
Yeah, you said that before.
Yeah. Yeah. I was
Like, no
oh my
idea what the
God.
origin of that was.
Wow.
Yep. That's a really good litmus test for like what somebody's generation is asking them, how do you pantomime that you're on the phone? Mm-hmm. Because
Right.
you see a huge break. Like we still do the thing where it's like the hang loose symbol and we hold it up
Yeah.
to our heads.
Yeah.
But kids don't do that anymore. They either do a flat phone or they like they're holding an iPhone.
Right, exactly.
Yeah. Yeah, like
Oh
those,
my God, yeah, that's awesome.
put a dial phone in front of a bunch of
Makes
kids and say,
perfect
okay,
sense.
here, make it work. Oh, what?
Yeah.
Or Monty Burns, who has like the daffodil phone, right? You have the two things. Ahoy, ahoy!
Ahoy, ahoy. Is this Bensonhurst 4215? Party lines. Oh gosh, forget it. You can go all the way back to the Telegraph playing this game.
All right, Bob, tell us about Neuralink's announcement. What's going on there?
Yeah, Neuralink has been all over the news a lot the past few days. Elon Musk said on January 29th in an X post, or a tweet if you want to be retro, I
remember
guess.
those, yeah.
He said the first human received an implant from Neuralink yesterday and is recovering well. Initial results show promising neuron spike detection. And that's it. That's all we know. Next
There he
news
is.
item. It's like, but it's not a hell of a lot more than that, except the backstory, which everybody really knows of, what's been leading up to this. So yeah, it's been like right now. This is like Wednesday night, 31st, and it's 48 hours since that tweet, and there's really not a lot new in terms of that specific thing. But if you haven't heard of Neuralink, it's a tech startup, right, founded by Elon Musk in 2016 to create brain-computer interfaces, BCIs or BMIs, brain-machine interfaces, which I guess that initialism is a little bit more common. So these are devices connected to the brain to allow people to interface with computers just by thinking. Neuralink's specific device is coin-sized. It's like a coin-sized chip designed to be implanted under the skull so that its myriad of tiny wires could be inserted a little bit into the brain to read the nearby brain cell activity. So now having the chip under the skull and the wires in the brain, it's certainly invasive and more risky, right? Mm-hmm. But it allows for a much cleaner, easier to interpret signal than, say, the classic electrodes on the scalp scenario. Now, Musk has said in the past that ultimately his computer's technology could allow people to form a sort of symbiosis with AI. That's kind of like, to help avoid or to help deal with the transition with artificial intelligence and artificial general intelligence and all that stuff. But they've already run trials in pigs and monkeys, and just recently, apparently, human trials have begun just very recently on a quadriplegic volunteer. Now, details about as I said, the details are very sparse about this person and the operation and what happened. Even Neuralink hasn't had an official announcement yet. What we do know, though, comes from subsequent posts to that previous post about the chip. The chip that was implanted is called telepathy, and Steve, understandably, isn't sure how he feels about that. But I kind of like it. I like that it takes an iconic bullshit paranormal ability, telepathy, and shoves it into a completely scientific corner. It's like just making it about science and technology and not about something that's paranormal. So from that angle, I kind of like it, I think.
It's also a spell in Dungeons and Dragons, by the way.
Nice. But so Musk also posted about telepathy. He said that it enables control of your phone or computer and through them almost any device just by thinking. Initial users will be those who have lost the use of their limbs. Imagine if Stephen Hawking could communicate faster than a speed typist or auctioneer. That is the goal. So that's what he posted specifically about telepathy. Kara, that brought back memories of you relating once on a show a while back about actually meeting Hawking and describing how time-consuming it was for him to put together even simple sentences. Right? It was an ordeal. It took serious effort and time. So if this did come to fruition, then for anyone like Stephen Hawking who has really just can't really type or interface with a computer in any realistic, normal way, this could be amazing. Now, of course, the whole Musk angle to this just muddies the water. He's totally polarizing, obviously. Most, though, I think would agree that at the very least he is a hype machine, among other things, of course. But the bottom line, right? The bottom line here, though, is this. I know I'm not going to dwell on Musk himself on this. I want to see what is this technology and what do we know about it at this point. The bottom line, I think, though, with this is where is Neuralink and the telepathy chip on the spectrum that has, on one side, the Tesla reusable rockets, right? And on the other end of the spectrum, Hyperloop. Where is it on that spectrum? So, and of course, we can't really answer that yet. The fact that this wireless chip has been implanted in someone's brain is not really especially noteworthy in and of itself. It's more of like, all right, big deal kind of in terms of this not breaking any new ground. The proof of the pudding in this case is in the tasting, as they say, or not too many people say that whole expression. The next days or weeks are going to be the real answer here. It's going to answer the critical questions, like how well does it function? How long is it going to last? Those are the things that are going to really be of interest. I mean, there's other companies that are considered more cutting edge than Neuralink, for sure. One example is BlackRock Neurotech. They've implanted more than 50 brain-computer interface chips, more than 50 already. I think a lot of people consider that they probably will have the first commercial device, right, Steve? Is that a fair?
They seem to be at the head of the pack right now.
Yeah. So the contribution that this telepathy chip and Neuralink in general will make to the whole BMI industry, it remains to be seen, of course. But I'm hopeful a little bit, if for no other reason that it's focusing attention on this technology and perhaps even intensifying competition and accelerating research to a certain extent. So from that point of view, I think this is a good thing. But then, of course, the other side of that coin is, there could potentially be a backlash of sorts caused by incessant overhyping, right? I mean, we've seen that with other products. Even we've seen it with artificial intelligence through the decades. It goes through a period of just overhyping. People invest money, and then the results aren't there that were anticipated, and then it goes into what they call it for AI, like a winter, a dark winter or something, where it just like you don't hear about it for a while, and then of course there's another big innovation. And then people are talking about it again, especially with AI, with ChatGPT. That was one of the big, huge developments that really has everyone still speaking about it all over. It's all over the place. So regardless, I think BMIs, brain-machine interfaces, they're, in my opinion, a no-brainer future technology, so to speak. Like that one, Evan.
Yes.
Like fusion, it's just a matter of time. I think we'll have commercial products with this before we have working fusion, for sure. The BMI research of the past couple of decades has been incredibly encouraging, as Steve says quite often. If we've learned anything, it's that thanks to neuroplasticity, the human brain is eminently hackable. Even Dr. McCoy in the 23rd century didn't have the tech that we have now. Roddenberry totally failed on that one. We are far beyond in 2024 we're far beyond Pike's goofy yes/no beeps from his wheelchair. Right? It's just like
they have
it's ridiculous.
nacelles and antimatter chambers and other things, but they have a yes/no beep machine.
Right?
There's a disconnect there.
It's so funny. I mean, I guess in the 60s, even a forward thinker like Roddenberry was like, yeah, no, we're not going to get. How do you hack into the brain? It's such a black box. And it was, of course, much more of a black box back then than it is now. And if you want to learn more about brain-computer interfaces in the future, check out Chapter 6 from the Skeptic's Guide to the Future. That was really. I just reread that for this talk, and it's such a good chapter.
Yeah.
Yeah, I'm done with this.
So I actually think, though, Bob, that the most promising technology for the medium term, for now, is the stentrode.
Yeah, that one's fascinating as well. Yeah. Yeah,
so that one
is that a portmanteau?
Because it's a stent that's an electrode, stentrode. So the idea here is that we want to maximize resolution, right? And that means to get the greatest number of electrodes distributed over the brain, with the greatest fidelity. But the problem with that is that it's invasive, right? It's in the skull. It's inside the brain. The stentrode, I think, is probably the best compromise we have right now because
it's in a blood vessel.
Yeah, they put it in your vein. They put it up in the vein inside the brain, so it's inside the skull. It's very close to brain tissue, but it's still invasive, But it's way less invasive than cracking open the skull and putting something next to brain tissue. These probably will have a greater longevity, so they're probably safer and with more longevity than putting electrodes on the brain. And the resolution, I think, is fine. It'll probably be a while before that's not enough resolution. And the other thing about that...
With AI.
With AI, sacrificing a little bit of resolution for a much safer technology may be the way to go because it turns out like the new AI applications are pretty good at interpreting or learning how to interpret brain signals.
That's what they do, man.
Yeah.
Take a massive information static, basically, and here are the patterns.
Yeah, so we've kind of taken a little bit of a leap in the software end of BMI because of these large language model, AIs, these transformers, and while the hardware is incrementally advancing. So if I were a betting man, if I had to put my nickel down, I would say we're going to probably, the applications over the next 20, 30 years or so are probably going to be more, I think the stentrode approach has more promise. But then eventually when you really get mature technology where you have soft electrodes that are more, biological, where putting them, interfacing directly with brain tissue becomes a lot more safer, lasts a lot longer, then that technology may eventually take over. Right. Anyway, we'll see. We'll see what happens. It's been a fascinating story to watch it unfold. This, the Neuralink is just one little blip on the radar for this whole industry. As you say, Bob, it's not cutting edge. It's not pushing anything forward. It's just, it's a good entry into this very small group, and hopefully it will push the whole industry forward.
Right. Another player in the game.
Yeah, it's just another player in the game. All right. Thanks, Bob. Jay, tell us the effects of being in love on the brain.
I love this story.
Yeah, it's a little weird when you really think about it. Like everything that we are, all of our thoughts and everything, there's so much to do with just chemicals, right? We have the wiring in our brain and the ways that our brain communicates to different parts of itself at the same time. That's called parallel processing. But there's a lot of stuff that happens in our brains because of chemical releases and the detection of chemicals by other parts of the brain. So this groundbreaking research that was recently conducted by CU Boulder neuroscientists, and the team was led by Zoe Donaldson. They tested the neurobiological underpinnings of how relationships are formed and how they are maintained. So the study was published in the journal Current Biology, and they utilized these prairie voles, right? These are little mouse-like mammals, and they used them to investigate the role of dopamine in intimate relationships. The research studied the biological mechanisms behind our preference for certain individuals over others, right? So, a lot of people we're in a relationship with one person, it's very common, people get married, they fall deeply in love with someone. So there's a lot of stuff going on here. So their research focused on the role of dopamine, which is a key neurotransmitter associated with reward and pleasure. They picked prairie voles in particular because these mammals have a rare behavior. They're monogamous, and this is similar to human beings, right? So of course we want to study what's happening in their brains, because there's probably some commonality between their brains and our brains. Voles form long-term partnerships. They cohabitate. They raise their offspring together. There's lots of commonality between them and humans. They also show signs of grief if they lose their partner. And studying voles can give the researchers insights into, human bonding and loss and, what is happening in the human brain. The study found that dopamine plays a critical role in sustaining love and desire in relationships. That is pretty remarkable, because it's not just like the initial feeling of falling in love with someone. It's there throughout the relationship, right? Which is it's pretty significant find that they came up with. The researchers used advanced neuroimaging technology, of course, to observe real-time brain activity in these voles, and the experiments were designed to mimic relationship dynamics. So this was an interesting part, because they're trying to create circumstances where the voles are trying to find their mate, or spending time with other voles that aren't their mates, or the loss of a mate, right? So the study ran these different scenarios, and the voles had to complete a task like pressing a lever, or climbing over a barrier to reunite themselves with their partners. So the research showed significant increase in dopamine activity in the nucleus accumbens, right? I'll explain what that is in a second. When the voles were with their partners compared to when they were with strangers. This area of the brain is known to motivate people towards rewarding experiences, and it's activated during pleasurable activities. I read up on it. It's actually a lot more complicated than that, but that's a good quick summary of what's happening in that part of the brain. The study found a stark contrast in dopamine responses when the voles interacted with their partners versus, some rando vole. This points strongly to the concept that there is unique chemical imprinting going on left by specific individuals on our brains. Now that right there, that sentence was the one that really caught my attention. So what they are saying is that the unique feeling, or the feeling that you get with a particular person in a particular relationship, it has a dopamine signature that they are saying you identify, you develop with that person, and it has an imprint. Your brain wiring changes, and the chemistry of that is specific to that person. I find that remarkable. So another interesting part of the research was when they tested an extended separation. Now, this was only for 4 weeks, but to the lifespan of a mouse, 4 weeks is much more significant to them than it is to us. So 4 weeks is a very long time for them to be separated. What happened was the vole's dopamine response to their former partner had diminished over that time. This is like, they described it as almost erasing the fingerprint of that specific desire, which is for that specific vole or partner. So this suggests a neurological mechanism enabling the formation of new bonds after a loss. So this, I guess, explains why you could develop a new relationship after one ends. I don't know what the parallel time would be, 4 weeks to a vole, what it would be to a human.
Mm-hmm.
And I guess some people get over these things quicker than others, but there are people that
there's a lot of human differences.
Yeah, without a doubt.
There's a huge range, yeah.
Massive range, right? There are people that lose their partner and they never, they deliberately never seek out another relationship, and then there are people that turn around and can get back into, just a deep relationship as the previous one. So the researchers said that, of course, more research is needed to narrow in on how these results apply to humans. They know not to say that this is a one-for-one, that this is just the beginning of understanding what's going on. The study offers hope for developing new treatments for individuals that struggle with forming close relationships or coping with prolonged grief disorder. The more they understand what healthy bonds look like in the brain, this could lead them to identify therapies for mental illness affecting social interactions. There's a lot to this, and there's a lot of good things that can come out of it. A lot of science is done, and you might like hear about a study and go, why did they do that? And it's somewhat unpredictable a lot of times, like how that information or that study or the conclusions that they came to could be used in other studies or push something forward that turns into something that is very effective. I find this to be fascinating, right? Because when you think about the feelings that we have, it's not just love, but all of our feelings are wiring and chemicals. When we feel those feelings, there is a release of chemicals that do things in the brain. And I just think, of course, Steve thinks this is so fascinating. He became a doctor of neuroscience. But I just like reading about this because it really it tells you, what, as mysterious as love might be, we are starting to understand what's happening chemically in the brain that makes it happen.
Mm-hmm. I have a question. Jay, you mentioned this dopamine signature. So what is the difference between the dopamine signature between two different people that you happen to love? What is it, what makes it a signature that's distinct? Even say you love two people very much, but would they still have a different signature?
What I gather is that there is, first of all, there's the initial attraction, right? Like they were saying, the researchers were asking questions like, why would somebody be attracted to this person and to not that person, right? Like something that we don't have control over. It just it's there. So there clearly is a hardwired type of preferencing going on in our minds.
Well, but you can't conclude from that research.
Can't say that.
You can't say it's hardwired or that you're born.
Yeah,
with
it could be learned.
Yeah, it's easily there at the time, but you don't know how much of it is learned culturally.
Yeah,
but it's very likely heavily
predisposition.
Learned.
Yeah, I mean, you're right, Steve. You could be born with it. It could be a mixture of being born with it and exposure and whatever. But you do have.
Well, we know it's a
there.
heavily learned experience because different cultures have different versions of what they find beautiful.
But it's there, right? We have a preference, right? Like you could talk to ask yourself the question, like what kinds of people am I attracted to? Is there a pattern there? I certainly have one. So anyway, so that's in play, and then you find somebody, you have like this, oh, okay, I'm attracted to this person, right? That's going on. And then from there, you develop a relationship with them. And from what I gather, your brain is basically strengthening whatever pathways are firing and however the dopamine is being released, it becomes stronger. And then if there's absence and you're away from that person for a long enough time, it could actually diminish and start to go away, kind of like when you use it or lose it kind of idea, right?
Yeah, not the first research to do that, but this is just adding one piece to the puzzle. There is research in humans where they have the subject looking at photos of people and like their spouse is thrown in the mix, and you can absolutely measure differences in the response, to people when they look at a picture of somebody that they're in love with. But the particular research that I'm thinking of, people fell into one of two categories. I think they called them doves and swans, where some people, even if they've been married for 30 years, still have the in love, dose of, I think it was oxytocin is what they were measuring, whereas other people don't. They just lose that after a couple of years or a few years. So they're. But
it would be really interesting to compare amorous love to like the love of your children and see if the dopamine signatures are really all that
things,
different.
Right?
I don't know if we have that level of resolution yet.
Yeah, so it's interesting, but it's also interesting how different people are, right? There is no one answer. Like all people don't react the same way. And it's probably the same as probably true of voles. Why would they all be the same? All right, thank you, Jay.
You're welcome.
So, guys, we finally found Amelia Earhart's plane.
Did we really, though?
Maybe.
Or did we?
Come on.
Definitely maybe did.
You guys are skeptical? I mean, come on.
Definitely maybe.
we have the fuselage and the wings and the tail and
This has been obviously a big missing person aviation mystery for decades, since 1937, I think, when her plane went missing. Amelia Earhart was a beloved and famous explorer, the first woman to fly solo across the Atlantic. And, the whole world was sort of rooting for her as she was trying to make a solo flight around the world. She was the solo pilot. She also had a navigator, so that Noonan was his name. He was on the plane as well. But on essentially the last leg of the trip, of her journey, the plane disappeared. Right? And it was, it was a really emotional thing, I think, for the world, and it's been a mystery ever since. And every now and then, somebody claims that they have some clue about what her fate was, right? Often it involves her having survived, a crash landing, and she's was taken captive by the Japanese, or she was on this island or that island. But the evidence always evaporates when you get too close to it. And there have been, several massive attempts to scour the ocean floor looking for the remains of her American Lockheed 10E Electra plane, and no one's ever found it. So now we have another effort to do that, and they're claiming that they have found a potential sonar signature that could be her downed plane. So this is the researcher here is Tony Romero, and he has been fascinated with the Amelia Earhart story for a while. And, he's looking for something exciting to do in his sort of retirement phase of his life. He bought a $9 million underwater drone from a Norwegian company
Nice.
called the Hugin 6000 referring to its range down to 6,000 meters, 19,700
Nice.
feet. Yeah, nice. He took a 16-person crew on a 100-day search mission from September 2023 to December 2023. They scanned 5,200 square miles of sea floor. And then at the time, they didn't, while they were on the mission, getting the data, they didn't notice anything. But when they were in December, when they were going over all of the data, they found a sonar signature. So it was found about 100 miles away from the Howland Island. That was the island she was trying to find when she ran out of fuel, probably, and crashed into the ocean. So that's a pretty good location. So that location, I think, gives some credibility to the find. Now, have you guys seen the picture of the sonar image?
Yeah, I did.
Yeah,
Yes.
It's pretty not impressive, right?
It's blob squatch.
Yeah, I mean, so is it in a plane-like configuration? Sure, there's a central fuselage, and there's two symmetrical wings, and there's something on the back.
Something on the
So could that be a plane? Sure, but the details aren't a good match for a couple of reasons. One is it's missing the engines, right? There's no signature on that radar signal that would be the twin engines of the plane. And two, the Lockheed that she was flying had straight wings, and this one appears to have swept back wings.
Absolutely.
Yeah, absolutely. I mean, the image has the wings appear swept back in the image unequivocally. But does that mean it's not her plane? Case closed? No, they say, well, because we don't know what damage the plane took. In the crash and on the way down, the wings could have been broken off and then been pulled back as it went down through the water. And we also, the sonar is fuzzy and it distorts the image, and it could be distorting it in just that way, so it's not definitive. We could say, number one, it could be a plane, but it's not necessarily even a plane. Two, if it is a plane, it's not necessarily Amelia Earhart's plane, and we're not seeing specific signatures that would make us think that it is specifically her plane, except for the location. That's the big thing, is that the location's pretty good for where her plane probably went down.
Did they mention? I wish they had a test case. In other words, something is a ship that they found that has been verified as a sunken ship, and let's see what that looks like on a sonar image like this, right? As sort of like a test or a baseline. Because what we're looking at here with this single image of the supposed possible aircraft, there's nothing to reference.
Well, but you could find pictures, Evan, of sonar images of the ocean floor where you see a smudge and it turns out it was a ship. So I mean that's not unusual. And some are better than others. Sometimes you could say oh yeah, that's a kind of a ship outline. Sometimes it's there are features that are pretty specific where you could say, oh yeah, this was definitely a ship. And other times it's I don't know what the hell that is, but
right.
Okay, is that a ship? Okay. The thing is, you can't say one way or the other, no matter how good the sonar image looks, until you have some either what we call forensic evidence or basically close-up pictures. So this is like a preliminary study. It's not a confirmatory study. It doesn't tell you it is a plane or it is her plane. It just tells you, oh, this is where you want to look, right? And so the next step will be to send down an uncrewed drone with cameras on it, right? And like they did with
Titanic?
The Titanic, yeah. And then you want to basically close up, well lit video of whatever's down there. It's possible. I mean, some of the experts are saying, hey, that could be a geological formation for all we know. The thing is, keep in mind, I told you that the size of the area they were looking at. They were looking at tons of sonar images looking for something that looks like a plane. The fact that they found something is not that surprising. This could be the Bigfoot on Mars thing, right? If you look if you're looking through a lot of images looking for something, you will find it. Although in this case, they're not looking for anything unusual. They're looking for specifically a plane. But the plainness of that image is, it's enough to say, yeah, it could be a plane, but it's not a home run,
With you have to understand they're invested in finding it as well, so that plays into this calculation.
But still, whatever. They did what they did, right? They got the best information they were ever going to get from this mission with sonar. And so this is just, they found a potential target. It wouldn't surprise me if it's nothing. It's like a face on Mars kind of illusion. Wouldn't surprise me. Wouldn't surprise me if it's just some other plane. A lot of planes go down in the ocean. You'd be surprised.
They do, but what materials whatever the material was made out of in 1937, whatever alloy. And what we're talking, 90 years later almost.
Also, every plane that has ever gone down should be accounted for.
But they're not.
There should be documentation.
Yeah. They're not all accounted for.
Well, they're listed as missing and unaccounted for.
Especially
exactly. But that's what I'm saying. There shouldn't be a plane that was in the air that wasn't accounted for.
Yeah, but during World War II, Carol, a lot of stuff went down that, we didn't necessarily specifically track. Secret missions and stuff like that.
That's rough.
Evan, to answer your question, they specifically said that at this depth in this location, the water is cold with a very low oxygen level, and so the plane could be very well preserved because of the conditions. Okay. Yeah.
Yep.
So if there is a plane down there, it could be there could be like the call letters on it. There could be definitive information. That's the forensic information like that. Yep, that's not only a plane, that's her plane. So at this point, I would say everything is on the table. Anything is possible and plausible. But we don't know anything until we send a camera down there and take a direct look and see what it is.
When's that going to happen?
They're planning it, so I don't know, year or two, I don't know, something like that.
You mean we don't have anything called Google Ocean yet?
Yeah, right.
They've sent a bunch of ships down there to take pictures.
They do, but it just shows the surface.
So then the question is, here's one final thing. If, let's say, they send a sub down there with cameras and it's her plane. It is her Lockheed plane. What do you do with it? So he's talking about maybe we could raise it and put it in a museum, right? And that would certainly be interesting. But
what would that cost?
It would cost probably $200 million to do that. Forget it.
It's not worth it.
Whoa.
Map it in fine detail and then 3D print it.
But international standard, though, is to leave it in place.
Right. It's a burial site, technically. Not
only for that, Evan, that aside, just scientifically, there's information that you could get from it being in situ, right, in place. And if you move it, you will destroy archaeological information.
That is true, absolutely true, yeah.
And who knows what future technology might have, that we could use. And so what you should do is document it as best as you can in place and leave it there. That is the standard. But so then the question is, well, who gets to decide? Who owns the plane? And there's controversy about that.
Oh.
Yeah, Tony Romeo, he thinks that the Smithsonian owns it. However, Purdue University, I think because they funded something or whatever. But I think he wants them to because then he'd be able to go get it. But the Purdue University says that they bought the plane for Amelia Earhart and she was always going to return it to them when she got back, and so they own it.
Yeah, the plane has a title of some kind.
They probably have the best claim to it.
Sounds like a good claim.
They're probably going to want to leave it there.
Does anybody have claim to that portion of the ocean?
No, it's international waters.
So wait,
Okay.
Steve, if I went and I somehow retrieved that, I'd have to give it to them?
So, the question is, you wouldn't
It's
really
not-
even have the rights to retrieve it.
It's
So
not yours.
It's not
yeah.
salvage, right? It's archaeological find. So
Right. That's like going and just like digging up an old burial site and being like, I just
Yeah.
did it because it was there. Like you didn't have permission to do
I was
that.
there. I found it. It's mine. Yeah. So
Yeah.
and you, as I'm sure you all know, the governments are getting really picky about that sort of thing and recognizing the rights of indigenous people to their own artifacts. Museums are like returning all the stuff they've stolen over the last couple of 100 years and taking down displays of burial remains that they didn't have permission to put on display. Well, everyone, we're going to take a quick break from our show to talk about our sponsor this week, Vessi Shoes.
So if you don't know, Vessi shoes are super cool, super stylish, really, really comfortable. And my favorite part about them is that they're breathable, but also waterproof at the same time. I don't know how they pull that off, but they do. And it's actually more than just waterproofing. They're an all-weather solution. So they keep your feet dry and comfortable in any condition. They're really lightweight. They're easy to wear even around the city. And yeah, they're super comfortable. Did I mention that?
Yeah, Kara, I got the weekend style. It's awesome. I don't know if you did this, but I tested mine because they say that they're waterproof. So I tested it and I poured a glass of water on the shoe. And it did. It repelled all the water. It's definitely hydrophobic.
Embrace your urban landscape with Vessi's all-weather shoes. Visit vessi.com/SGU now to discover footwear that's as functional as it is fashionable and get 15% off your first purchase. That's vessi.com/SGU for 15% off.
All right, guys, let's get back to the show. All right, Carol, let me ask you a question. If you're sick, do you ever go to work and like pretend you're not sick?
This is an important question. And apparently, according to some new research of their very large sample, over 70% of people do that.
Yeah. Whoa.
Yeah. So
For a lot of different reasons, I would imagine.
for different reasons, mostly social in nature. Surprisingly, yes, some of them have to do with like institutional pressure and stigma, but not as many. So there's this new study, I guess I should cite it first, called When and Why People Conceal Infectious Disease. I love psych papers. They have the most straightforward titles.
Right.
Yeah. So this was published by a PhD candidate who was interested in this very topic from the Department of Psychology in Ann Arbor, at University of Michigan, Ann Arbor, along with some colleagues. And they were, curious, like when and why do people conceal infectious disease? And they looked at the literature to try and paint a picture of what we already know about this. And then they did 10 different studies. And those 10 different studies looked at different things. We won't go through all of them. We'll kind of summarize them. But across the board, their sample size was 4,110, mostly university students, as is typical with psych departments. But they also looked at healthcare employees, and then they also crowdsourced different people with jobs online. And all of this is self-report. So we have to sort of, I don't want to say we have to take it with a grain of salt, but we have to know that's sort of an important context for how we talk about this. Everything that I'm going to say has to do with, is self-reported. So what they found, we'll do the big top lines first, is that 75% of participants on average admitted to hiding or considering hiding an infectious illness. More than 61% of healthcare workers confessed to concealing their illness. My assumption is that when you see these numbers, they're either accurate or low. They're probably not high. I don't think people are going to say, yeah, I've lied about that when they haven't.
Yeah, right.
But I do think people are going to say, no, I've never done that when they absolutely have.
Yeah. Much more likely, yeah.
Yeah, much more likely. So when we say 61% of healthcare workers confessing to this, that it may be more than that. And then also there does seem to be a difference between when people are well and they are estimating how they would act once they're sick versus the way that people say they act when they're actively sick. So in one of the studies, they didn't just interview people and say, hypothetically, what would you do? And they didn't just interview people and say, in the past, what did you do? They found sick people and said, what are you doing right now? And they found something really interesting in those different study paradigms, that when people are well, they think that they are going to be less likely to conceal their illness. They also found that there is a continuum. They are more likely to conceal mild illness, and they think they're less likely to conceal severe illness. But these studies showed that people who are sick are just more likely to conceal their illness across the board. There's no discernible difference between mild or severe illness.
Oh, really?
And so there's something kind of interesting happening here. And I love talking about this phenomenon. And I don't know if there is an actual like coined construct for it, but I know we've talked about this on the show before, how like it's really hard to empathize with yourself when you feel a different way. Like it's very hard to empathize with your depression when you're not actively in a depressive episode. Or it's very hard to empathize with what you felt like when you were sick. Like you can kind of remember it, but it's really hard to go there in your mind.
Yeah.
And so I think this shows that in some ways, that people are like, oh, if I'm sick, I definitely wouldn't want to go to work. And then as soon as they're sick, they're like, I got to go to work. And they go to work. So the other big takeaways from this that were really interesting is, like I said before, most people cited social either obligations or just interests in why they concealed it. They wanted to get on that plane because they were looking forward to that travel. They didn't want to miss the concert. They were really looking forward to spending time with their friends. Some people did cite institutional pressures, but that was a significantly smaller portion of the variance. So that's also pretty interesting, because if you were to ask me, I would say that probably most people would say, oh, well, I can't miss work. That's why I had to go. I don't have any more sick days, or I can't afford to not get paid, or, you know, they're going to get pissed at me if I miss. And to be fair, this happened, they looked at a lot of this stuff during COVID. So they weren't just asking people, how likely are you to lie about being sick? But they also asked them, like, how likely are you to falsify a school mandated, like at their university during COVID, you had to basically like sign something when you came in, you know, like symptom screeners, you know, like I have not had a fever, I have not had a cough. And so that was one of the components. It was, are you covering up symptoms? Are you coming to work or school without telling people you're feeling sick? Are you falsifying symptom screeners? And they did see that people, the highest percentage of people reported covering up their symptoms, but also people did say that they falsified symptom screeners, or they came to work and just didn't say anything about being sick. So they didn't actually, quote, lie in their minds. They just concealed it, which is lying. You know, what's the big takeaway here? Because I don't think this surprises any of us. Maybe the magnitude of it is surprising, but I don't think it's a surprising thing that as human beings, people are likely to conceal how ill they are in order to continue to go to their social obligations or to continue to go to work or school. I think the thing that's worrisome here, at least for me personally, and I'm curious what you guys think about this, is how, you know, if you remember during COVID, a lot of the backlash was that some of the measures were quite draconian. Like people were not happy with being forced to wear masks, or with having mandatory temperature checks or things of that nature. But research like this shows us that this cannot be an honor system.
Oh, yeah.
You know, people aren't going to, they're always going to paint themselves in a light that is the least, I guess, revolting or frightening. And that's, I mean, it makes sense evolutionarily, right? Like you don't want to be around somebody who's sick. You don't want to get sick. Sick people are like gross to us, and sick people are scary to us. And especially when we're talking, this whole entire study was looking specifically at infectious diseases. So contagious sickness, like things where if you coughed or sneezed in public, somebody else might catch it from you. They did do a whole, just as a caveat, I should say, in many of the studies, they actually did carve-outs for COVID simply because of the stigma around COVID. I think that they were afraid personally that they weren't going to get honest answers, because like at the time, people know I would never go to work if I had COVID and knew I had COVID. What kind of a monster am I? You know, I do think that's different now, but at the time there was so much stigma around it that they didn't want to include that in most of the studies because they were afraid they wouldn't get very, I think, honest responses.
Yeah, I mean, I think a lot of it is cultural. You know, there is, and certainly within healthcare for physicians, there's a lot of pressure to tough through a lot of hard situations. You know, that's just sort of the culture.
Which is funny because also in the same you could say in the same breath that for many physicians, there's a mandate that they can't go to work if they have an infectious disease.
There has to be that has to be the case, and that's why I agree. Like, it shouldn't be just left up to 100% discretion, because then you have that conflict of interest where, like, I don't want to seem like a weenie. I don't want to dump my patients on all of my colleagues, or because it is burdensome. It's not a little thing, you know. Like, I was the inpatient attending for a couple of weeks early January, and I got sick, and I kind of know who gave it to me, but that's all right. You know, so, you know, whatever. I got really sick, you know, and I felt bad about having, you know, I had to call
the backup. Yeah,
I mean, the person in charge of the ward service would say, "Hey, I'm sick," you know. But there are specific protocols. I had to get 2 negative COVID tests 2 days apart. So I did everything I could very diligently, but still, it was a huge burden for me to just suddenly have to miss 2 days of inpatient service. People had to, like, interrupt their careers for 2 days and come in, cover my ass. Yep. But I had to do it. So, but the pressure was, but even still, I was following protocol. I still felt the social pressure. It's, oh crap, I'm being a weenie and dumping on my colleagues.
And that's in like a white collar position. You know, you think about people who during COVID, especially, were working in like farm settings, or were working in like meat packing settings and things like that, where like, they're like, I can't not go to work.
Yeah.
Like, if I don't go to work, I don't get paid. If I don't get paid, I could lose my house. You know, it's like you have all these things. So you've got the institutional pressure, you've got the kind of internal pressure. But then you also, and again, I think that says something about this study, that it was mostly looking at healthcare workers and university students, that their main reasoning was social pressure. They didn't want to miss stuff, you know, and that could just be saying something about the actual sample. This was college students and healthcare workers mostly, and an online sample. So the researchers did say the next step is they're super curious about culture and looking at people from different cultures and at different SESs to try and understand how some of these responses might change.
All right, Evan, tell us about this double brood.
The double brood, yes.
Ooh.
I know. And we knew this was going to happen. It's been on the calendar, only a matter of time. But now we are just weeks away, a couple months, from the emergence of North American cicadas. That's an occurrence that takes place in the early spring on some very specific years. So specific that, you can mark your calendars by it. Cicadas live the vast majority of their lives underground. We're talking about billions of these insects all over the eastern regions of the United States. Some of the cicadas will emerge, and it's a predictable cycle where cicadas in specific regions make their emergence either once every 13 years or once every 17 years. And those emergences are called periodical broods. But 2024 is special. We have a BOGO, buy one, get one, or a brood one, get one. We have 2 periodical broods emerging at the same time this spring. Yep. And this is a less than once in a lifetime experience. The last time these 2 specific broods emerged at the same time, 1803.
Whoa.
Yeah.
Thomas Jefferson was president. And the next time it will happen, 2245. Yeah. So not even a once in a lifetime event.
That's like Star Trek time. Jeez.
So last time, did people literally think that it was like some biblical shit going on?
They always do. They confuse it sort of with like a locust plague, and absolutely it takes on sort of a biblical meaning to it. But it's certainly not a locust plague. There's no destruction involved. Thank goodness, with the cicadas coming along. So cicadas, real quick, here's how it works. They start their lives as eggs. The females will lay 200 to 400 eggs into tiny holes that they make in the branches of trees and shrubs. And after 6 to 10 weeks, cicada young called nymphs hatch from the eggs and immediately fall to the ground. Then they burrow underground and they attach to the tree roots. The nymphs stay buried to suck the tree sap of the roots for anywhere from 2 to 17 years, and that depends on the species. While underground, that's called the dormant period, and when it ends, the cicadas emerge above ground at sunset when the temperature of the soil is correct. They climb the trunk of the nearby trees, then they shed their skin, and boom, adult cicadas. then can live out their last few months of life above ground. Okay, so cicadas, what? They're bugs, right? No big deal. Tons of bugs, trillions of them, born all over the planet every year. What's the big deal? Well, cicadas, like all insects, they impact the environment in many different ways, but none are more impactful to environmental noise than cicadas. They are the loudest insects in the world. For example, there's an African cicada named Brevisana brevis, and it is the world's loudest insect. Its loudest song is almost 107 decibels when measured at a distance of 20 inches away. And by comparison, a chainsaw has a 110 decibel level. And there are 2 species of North American cicada, and they're second in the world. They come in at about 106 decibels. Yep. The cicadas, they have tymbals in their abdomens. They create the noise when they expand and they contract. The males use the noise to attract the females, of course. Oh, and they also have, they evolved a means of closing up their own ears when they're singing so they don't deafen themselves.
Oh, isn't that convenient
to
for
protect
them?
Protect them. To protect themselves from this enormous noise that they emit.
Evan, isn't their song like almost exclusively a breeding song?
Yes, it is, and each brood has a different one, a distinct one, which is part of part of also what makes it its particular category, its own brood. When the brood emerges, it gets going, the peak noise can overtake most other noises we hear in nature. Now, how many cicadas are there in a brood emergence? Many billions of them, of course. But here's something. The densest areas, there can be a concentration of 1.5 million cicadas per acre.
Yeah.
1 acre of land, 1.5 million of these.
Wow.
Could you imagine that? And then, okay, now you're going to have a double brood. Okay. Now, the regions of the 2 broods, and these broods are officially called Brood 13 and Brood 19. For these 2 broods which are coming, the regions in which they emerge, for the most part, they're in different areas, but there is going to be a little bit of overlap. So could you imagine if you do have an overlap and you get these 2 broods emerging with a potential density of 3 million cicada per acre? Ah, my gosh. That would be loud. Get your earplugs ready. I'm not joking about that. I mean, as someone who goes to concerts regularly and often metal concerts with my daughter, I know the importance of proper hearing protection. You have to have it or else you're going to damage yourself. The cicadas will be so loud in some areas, it's going to...
How loud will they be?
So loud that it will drown out the sounds of highway traffic where you live and airplanes flying overhead. There have been cases of people developing tinnitus as a result of cicada noise. Yep. According to the U.S., the CDC, yes. Hearing loss, damage to the nerve ending in the inner ear, thyroid problems to exposure to loud noises. And right now they say about 45 million Americans struggle with a disorder. Cicadas can impact that, definitely. When you're reaching 100, here's what they say. Cicada buzzing, it can reach 100 decibels, and 15 minutes of that exposure can be enough to cause hearing-related loss. So 100 decibels, a jackhammer in operation, or a revving of a Harley-Davidson motorcycle. Yep. By the way, so you can know on the map where to look, or in case you live in these areas, Brood 13 will be predominantly occurring in the, greater Chicago region of Upper Illinois, along with parts of southern Wisconsin and Iowa, plus other regions along the Lake Michigan shoreline. Brood 19 is more centralized to the state of Missouri, so most of Missouri will be impacted, but also parts of Illinois will be impacted. That's where potentially some of the crossover will occur, the double brooding in the same areas. But also Arkansas, Tennessee, and other states in the southeastern U.S., Brood 19 is considered the largest of the broods when they emerge. So here we go. Here come the cicadas. Double your fun.
I remember the last time they were out in Connecticut. Actually, I was visiting someone in Maryland. We're at a park, and I'm walking like in the park on the ground. There's like this millions of holes in the ground. Like, what were those from? Is that an ant colony? Was it? Then I remember, like, oh no, those are all. Every one of those holes is a little cicada.
Isn't that amazing?
Climbed out of. Yeah. It was
Amazing.
it was amazing.
Oh, and
All right.
and finally, Steve, I'll throw this in.
Yep.
Some people are calling this cicada apocalypse, just to kind of have fun with it,
Yeah.
So if you hear that word, that's what they're referring to.
All right. Thanks, Evan. Yep. Jay, it's Who's That Noisy time.
All right, guys. Last week I played this noisy. What do you think, guys?
Sounds like a video game.
Yeah, it sounds like a gun.
Yeah, it sounds like maybe almost had Tommy gun-ish from a 1930s movie with Edward G. Robinson.
Without a doubt, it totally sounds like a gun. So we had Visto Tutti write in. He said this noisy is the 1984 arcade game called Turkey Shoot, where a machine gun with haptic kickback was used to shoot turkeys on a video screen. I played, if I'm remembering correctly, I'm sure I played this game. He said, I'm not sure if the game was banned, but it sure would have been for its blatant anti-foul propaganda. It is not a video game, but that is a wonderful guess because lots of video games have sounds like that. Another listener named Michael Blaney. These are very frequent flyers here on Who's That Noisy. Michael says, hi, Jay. Gunshot is too easy, so I'm not going with that. So I'm going for an automated assembly line riveting machine. Looked that up. I couldn't find that sound to compare it, but I mean, sure. I know that there are rivet machines that that pound the rivets in as they're heated up, right? So I could see that, but that is also not correct. Then the last guess from this week, Liam Wenzlick, Wenzlick, Wenzlick. Got it.
Liam Wenzelick, maybe.
Wenzelick. He says to Who's That Noisy? Hey, I used to work at a steel, and it sounds like a hydraulic pecker on a digger pecking at slag. I would imagine that that's a machine that would probably break up the slag that falls when they're pouring the steel. The slag comes off, and they probably have to get rid of it somehow. That's about the extent of my knowledge of steel mills. But anyway, that is not correct. But then we got so many correct answers this week because apparently lots of people know a lot about this. But the first person to send in the correct answer, listener named Paolo Ciaroca, and he said, hi, Jay, long-time listener since 2014, first-time guesser. I think it's the call of the shoebill bird. And he's from Edinburgh, Scotland. And he said, I was a live stream guest during COVID lockdowns. So we have actually met via video call, and I vaguely remember you. I do remember you. So this is a very large bird. The shoebill is a tall bird with a typical height range of 110 to 140 centimeters or 43 to 55 inches, and some specimens reaching as much as 152 centimeters or 60 inches. That's huge. The length from tail to beak can range from 100 to 140 centimeters or 39 to 55 inches. And it could have a 260 centimeter or 8'6" wingspan. It's a huge bird.
Big bird.
So take a look. Look up the shoebill. Now this noise is generated by the shoebill, basically clacking its mouth open and shut really fast. This sound was taken, I think, from an interior, so that's where the echo is coming from. And the whining that you hear is the bird. So listen again. Now, Evan, talk about animals making noises. Oh my God!
Right?
Could you imagine living across the street from one of those?
I'd be ducking for cover if I heard that
right?
all day.
Oh my God, that's great noisy. Thank you so much for sending that in. I have a new noisy this week. This one was sent in by a listener named Marlo
Lemieux.
Yes, that's a cool name. So here is the noisy for this week. Not an easy one. So you could email me if you think you know what this week's noisy is, or if you heard something cool, because I really do appreciate those emails because they keep the show going. Email me at wtn@theskepticsguide.org. You guys can attach any sound files directly to the email because that, this isn't going through the website. So you just simply drag and drop the file that you want to send me so I can hear it. Some people send me in noisies and don't send me the sound files, and then I have to email them, and it's not easy for me. So please do include the file. We have stuff, Steve. We have stuff going on. So we are in our 19th year, and this year we will be achieving our 1,000th episode.
Oh,
whoa!
1,000 episods.
1,000 episodes.
Probably done about 400 with you, Kara.
400,
300.
300.
Yeah, I don't know.
All right,
probably more. No, I think it'd be more than that by
2015.
now. Yeah. So how many is that a year?
Roughly 50.
Yeah, so
yeah.
half of, yeah.
Wow.
So
all right, so we're up there too with Kara. It's a big milestone for all of us, and we will be announcing some plans that we have for that. We are formulating those right now, but we have plans that are already in place that if you would like to join us. So we have tickets still available for the Dallas Extravaganza. This will be happening on April 6th. That is April 6th. It is in Dallas, and you can easily go to the SGU website. That's the skepticsguide.org website. There's a button on there if you want to buy tickets for that. Tickets are selling out pretty quick, so if you're going to be there or if you're visiting for the eclipse, please come check us out. We also have a VIP available if you want to spend an extra hour with us at that show before the show, and you get some perks with that as well. So please do consider joining us on that show. The other private show, it's sold out. And, ticket sales went really quick on that. We were very excited. But for those of you who are going, we're looking forward to seeing you there. There's a couple things you could do to help support the SGU. One of them is you could join our mailing list. We send out a weekly email. You could easily do that on our website as well. Go to theskepticsguide.org. We have a link there to join the email list. We send out an email every week that is a summary of all the content that we've created the previous week. We're getting a lot of positive feedback on that email. So if you're interested, just please go join our list. You could give our show a rating on whatever podcast player you're using. I still think that Apple iTunes is one of the, is basically the one that most people go to get, information like that, like rating information. But please do, drop us a like or give us a review if you don't mind. That'll help other people find us. And of course, the absolute best thing you could do to show your patronage is become a patron of the SGU. You can go to patreon.com/Skeptics Guide. We are currently 600 patrons away from us having to fulfill the 24-hour SGU live show, which we promised that we would do when we reach 5,500 patrons. So if you guys are interested in seeing that, now would be a good time to join because it is actually coming up. I predict that we will end up probably having to schedule that show that, at some point this year we'll schedule it. I don't mean it's going to happen this year. We might have to push into next year depending on when it happens. But that's one of my predictions for 2024. Anyway, guys, thank you all for your support.
All right. Thank you, Jay. A couple of corrections that I want to do. A couple of times on the show, I've mentioned that when talking about the Artemis program, right, Jay, that the original timeline was 2028 for getting to the moon, but then the Trump administration moved it up to 2024, and now it's being delayed again. Now we're saying 2026, right, before landing on the moon. But I was...
No, not landing on the moon.
2026 just to go around the moon?
Yeah, well, the flyby, I think, was pushed to 25, and late 2026, we might have boots on the ground, but it's going to get pushed. Okay.
Yeah, 2026 landing on the moon unless it gets pushed again, right. But it turns out that that's incorrect, right? So I was basing this on the reporting at the time, and there are like the Washington Post, the New York Times, and then a lot of the space news is basically reiterating this notion that the original timeline was 2028 and it was moved up to 2024. But, I was emailed by Jeff Wakesman, who was, as he says, he was working at NASA HQ at the time, so apparently he knows that was never the case. That was basically misreporting. That essentially what really happened was that the Like the Obama administration wasn't that interested in deep space exploration. And then the Trump administration was interested in it, but Trump wanted to go to Mars. And it was actually Pence who pushed going to the moon. NASA, like basically saying we're going back to the moon and we're going to get there by 2024, that was actually Pence. And then when the Biden administration came in, there was a debate between the moon, what he called the moon Democrats and the Mars Democrats.
Oh gosh.
And basically the moon Democrats won.
That's awesome, man.
Yeah,
That's a smart move.
Which is a good thing.
Yeah, that is good.
But there was never this 2028 timeline. That was just a fiction. He's not even really sure where it came from.
There was a graphic I recall seeing, and I don't know if NASA put it out or somebody else put it out. I can't remember. But at the end of that timeline, they had it stretched across kind of just a bar. At the end, it did say 2028.
Yeah,
but an approximate.
So that's what he thinks. It was maybe from something like that. But it was never policy. Like, it was never a decision or a timeline that NASA had that we're going in 2028. That never existed. Might have been some analysis or whatever, as you say, some kind of chart or whatever. But it was that was basically just fiction. So, but having said that, the 2024 timeline was aggressive. It was very, very aggressive, and they knew that it was aggressive. It was partly for we want to make sure we beat China there. That was part of it. So it's not surprising that the timeline has been delayed, because the 2024 is probably the maximally ambitious timeline to begin with.
Yeah, remember, Steve, you said that when you go aggressive like that, that's actually a great tactic, because if you say, we're going to do it in 2028, then people kind of forget about it. They're not motivated to get the funds and to get the ball rolling. So when you go extra aggressive, like, oh man, we got to get started on this, and that really helps push it along. And if it gets pushed back a little, that's fine. But now you're committed, and it's like you already got the funds in there. The work has been a lot done. So it's actually a good move to be extra aggressive, or even maybe unrealistic.
It's probably good at the NASA end. Like, if you want to get there by 2028, say you want to get there by 2024.
Right, exactly.
But it's not great for a PR perspective, because then the repeated delays makes it seem like you don't have your shit together, and people get disappointed.
Everyone expects delays at this point.
I guess that's the counter argument, is that it's pretty expected, and we're not shattered by it. We kind of were expecting this the whole time. It's still disappointing, but
look at Jim. We learned our lesson from James Webb, I think. That to me, that was okay. Whatever they're going to say, you have to tack on more time, because this stuff is so complicated. Of course, it's going to take longer than they're expressing.
And I'd rather have them do it right than do it quick.
Of course, especially when there's lives at stake.
Absolutely. The next one has to do with a science or fiction. This is going back to the end of 2023.
Oh, wow. I barely remember that year.
Yeah, I know. It's like it's lost in the mists of time. Right? This one comes from a listener named Seth, and Seth was pointing out, so if you remember, there was a fiction item where I said that a company has developed a hydrogel that releases insulin slowly, so that you only have to inject once every 3 months to cover your insulin.
Yeah,
do you guys remember that one?
Yeah, I do.
And he was pointing out that there actually is it's actually a microgel with nanoparticles that does have sustained release of insulin, but this lasts for 22 days and is in mice. So I said, okay, that's closer than I thought, but that doesn't make it not a fiction, right? 3 months in humans, 22 days in mice doesn't render it fiction.
Yeah.
And I've done that before, like saying, like, this has been shown to work in humans. It's like, no, there's actually only mouse studies. I've made a science of fiction that way many times before. But so for a quick background, though, so for people who are insulin dependent, either type 1 or type 2 diabetics that are insulin dependent, there are different types of insulin that they use. There's sort of the basal insulin, which is like their minimum basal need of insulin, right? So they get that you can get a long-acting insulin to cover that. And then there's so-called prandial insulin, where like if you eat a big meal, then you got to take insulin right at that time to cover the glucose spike for that meal. So the problem with getting like one injection that's going to last for a long period of time is that really would work better for the basal insulin. And we already have that kind of longer lasting or like slow release insulin to cover sort of the basic needs. But then you still need to take the prandial like as needed. I just had a big meal insulin on top of that. But this new study was showing that the microgel can sense the overall level of blood sugar, of sugar in the blood, and therefore can release more insulin to cover the prandial dosing as well as the basal dosing. So that's why, like, even if you need both, you could still be covered for 22 days, at least in mice in the study, that was done. So that's a very interesting technology, and I hope this works out in people and they continue to push that forward. It would be great, again, if you're insulin-dependent diabetic, just to have to take one injection, you're good for a long period of time, rather than have to like measure glucose levels and inject yourself multiple times a day. But it doesn't change the fiction. And you guys got all this one right, by the way. You guys all correctly called that out as the fiction. So
Of course we did.
yeah. We are joined now by Dustin Bates. Dustin, welcome to the Skeptics Guide.
Hey, thanks for having me.
And Dustin, you're the lead singer of the group Starset. How would you describe your band?
Cinematic, hard music. There's some rock elements, metal elements, EDM. It's kind of across the gamut. But yeah, definitely cinematic.
What makes it cinematic?
Everything about it, from the music to the marketing to the visuals, is movie-esque. So... and we have a live violinist and live cellist, and so we bring in all of these symphonics to the music.
Have you ever recorded music for a movie?
I have not, but that would be pretty
That'd be
amazing.
awesome. Yeah.
The video game industry seems to appreciate your music very much.
Yeah, and it keeps growing, actually. We're in the middle of our next tour. We're going to China for 3 weeks for, I think, 8 shows in a row there.
Wow.
For a gaming convention, I guess. So
Awesome.
because
Yeah.
they used our music in
But
their
video
games.
games are very cinematic these days.
Dustin, I was looking up some pictures of the band, and I found this goddamn remarkable picture of your guitar. I'm not sure if it's you, because there's a helmet. You got basically somebody's wearing a sci-fi like spacesuit.
Yes.
That is so bad. What? How did that come into being? Like, tell me the backstory on that.
Yeah, there's a running narrative with the band, and in fact, there's a novel out, a Marvel comic out, and there's going to be a second novel out that actually drops in conjunction with this tour. But when we first came out, there was a space element to the narrative, and that first version of the spacesuit was homemade, the first couple, and then we started to get help, and this next tour actually is kind of going to be unbelievable. We have new suits, and they're just Hollywood ready.
Whoa.
That is so cool.
Awesome.
That looks like a lot of fun. I mean, you're basically in the band that I always wanted to be in, because there's like a science fiction backbone to it that really like sets the tone. I really, really like the look.
That's awesome. Thank you.
So, Evan, you actually hooked us up with Dustin. You want to talk about with him why he's coming on the show?
Yeah, I have to go back to 2019, Dustin, when Starset was performing in Hartford, and my daughter Rachel introduced me to your music, and she very much wanted to go to the show, so we decided to go. We got the opportunity to not only see the show, but also meet you. And based on what I had read and heard, I thought it'd be a nice opportunity to sort of introduce myself and our show to you, plus brought you a copy of our book. So that's where we first met.
Yep, I still remember it. That was a very memorable hang. Doesn't you usually don't get to talk about science and associated topics after a show, so that was very welcomed.
What was interesting when I was looking into your history a little bit is that you had studied at Ohio University electrical engineering. You were a PhD candidate there.
Yep.
And you also taught at the International Space University, something I didn't even know really existed.
Yeah, that was. It's an amazing. I did the summer program, and I went back and actually taught, and it was an incredible experience. When I was helping to teach and TA there, I think 25, and all the others, like the students were all older than me because you had to have a degree to even be a student. And places like Boeing and NASA sent students, and it's from all across the globe. And I met people that ended up being directors at SpaceX and Starlink, and so it was an incredible experience.
Certainly has had an influence on your music and all the work that you put into Starset.
I was in bands before this, and I feel actually lucky that they didn't. It got dropped unceremoniously. At the time it felt terribly, but I'm very much where I feel like I should be. This is a blend of all of my passions and nerdery.
Now, Dustin, you're going to be joining us in Dallas for the eclipse.
Yeah, it's amazing that the stars aligned for that. We, when I realized that the eclipse was happening, I was like, oh crap, we got to be on tour, and it has to be Cleveland or pretty much Dallas. And I'm pretty sure this tour exists the way it does because of this eclipse.
Interesting.
I'm super pumped for it.
Awesome. Yeah. So you're going to be joining us for something we call an SGU Private Show Plus, which means we're not just doing, a 2-hour live show, but we're going to hang out with the audience and do some fun stuff for another hour after that. So to be determined on what we're going to do, but everybody's talking about it right now. We usually, start talking a couple months before the show to come up with some new stuff. So I'm really looking forward to it. So
awesome. Me too. Can't wait.
Dustin, the next Starset tour is kicking off right around the same time as the eclipse. Where can people go for more information to see the show?
Yeah, starsetonline.com. There's still some tickets available. I believe most of the VIP experiences have sold out, but there's still tickets in 2/3 of the cities.
Well, having seen your show about, 7 or 8 times so far, I can't recommend it highly enough.
Thank you. And this is an honest statement. I think this is going to be the most wild and immersive one. We're having a ton of fun designing it. So I hope to raise the bar on it for you.
Dustin, we're really looking forward to meeting you in person when we're all together in Dallas for the eclipse and having you join us for our live show there. So thanks for coming on the show tonight and giving us a preview.
Thank you so much for having me.
Thanks, man.
Thank you, Dustin.
Thanks, Dustin.
It's time for Science or Fiction.
Each week, I come up with 3 science news items or facts, 2 real and 1 fake, and I challenge my panel of skeptics to tell me which one is the fake. We have a theme this week, and that theme is animal emotions. Actually, not inspired by Jay's news item, just a coincidence, because this was based upon something else I saw on the news. But there's three claims that have to do with animal emotions. Okay, you ready? All right, here we go. Item number 1. Most rats will stop pulling a lever to deliver a preferred treat if that lever also gives a fellow rat a small electric shock. All right, number 2. A recent study shows that goats are able to tell the difference between happy-sounding and angry-sounding human voices. And item number 3, capuchin monkeys are one of the few non-human animals to be shown to cry emotional tears. Evan, go first.
All right, rats. They will stop pulling a lever to deliver a preferred treat if that lever also gives a fellow rat a small electric shock.
Yeah, so apparently the study was asking the question, do rats have empathy? Right? And so apparently the answer is yes, if you interpret this study that way.
Okay, so the rat's pulling the lever, getting the treat at the same time it's witnessing another rat getting shocked, and it's making some sort of connection between those two events and sort of figuring it out. That seems like a stretch to me. Do rats tend to have more of a pack mentality to them? Like the damaging of one means everybody is going to suffer in some way, right? Is it part of a collective thought thought with other rats. I don't know. That one seems sketchy to me. The second one about goats being able to tell the difference between happy sounding and angry sounding human voices. That would not, I don't know that that would, I don't think that surprises me, because I think other animals have been shown to have that. So why not goats? Why would a goat brain, not, goat neurology not work the same way as perhaps some of the other animals like dogs who fall into that category? I think that one's right. And the last one about the these monkeys, one of the few non-human animals to be shown to cry emotional tears. Oh gosh, why did I think at some point I was told humans are the only ones who cry for emotional reasons, shed tears. So it's either that one or the rat one. And I guess, oh boy, it's one of these two. Gee whiz. I'll stick with my first guess. I'll say the rat one is the fiction, but I will not be surprised if I'm wrong and it's the monkey one.
Okay, Bob.
Oh boy. Yeah, these are good, man. I could kind of justify yes or no for any of them. I think I'm going to go. I think I'm going to go with the rat one. Although the interpretation that they have empathy isn't necessarily the best alternative. Couldn't they be thinking also like, oh man, look at, I pull this lever and that rat gets shocked. Maybe I'll get shocked if I hit the lever again. If they might be doing it out of self-preservation instead of anything out of that's empathic. But what the hell? I'll go with the rats
As the fiction.
as the fiction.
Yeah.
Yes.
Okay. Jay?
The first one with the rats, I mean, that one seems the most believable to me. It doesn't seem like that much of a leap to think that they would be able to tell when another rat is in distress. They just have to be able to connect the act of, getting the food with the electric shock. So I don't think that one is the fiction. That's likely science. The second one is the study that shows that goats are able to tell the difference between happy sounding and angry sounding human voices. Yeah, I mean, again, being able to detect a intonation difference doesn't seem to be that complicated to me. Why wouldn't they? Like dogs can do it really easily. I don't see why a goat couldn't do it. And the last one about the monkeys crying, I have never heard anything of a monkey crying in my entire life. I don't know. For some reason, I just don't think monkeys can cry. I think humans are the only ones that cry, except crocodiles.
Yeah.
Yeah, I think that was the fiction, Steve.
Okay, and Kara?
I'm going to go with Jay on this, not because I don't think other animals can't cry. I know lots of animals that can cry, but I don't think we've ever been able to link tears to emotion. Like animals have tear ducts. Like they can cry when they get shit in their eyes, but I don't think that other animals, I don't think we have any evidence unless this is like a new study that I haven't seen. And if they could find that a capuchin would cry sad tears, it makes no sense that like a chimpanzee or bonobo or orangutan or an ape wouldn't, because we're much more closely related to them. I do think a rat, again, like Bob said, I don't know if you would call it empathy. I might call it empathy. I don't know. I mean, it's a construct, whatever. But rats are really smart. Rats are very, they can't puke. So if they see another animal eat poison, and then if they see another rat eat poison and then die, they won't eat that poison. So I think that they would watch and be like, oh crap, this is shocking, that animal. I don't want to do that. And then goats are super similar. They're social animals. They're very social. They're, they're domesticates. They were raised in farms. Of course, they're going to be able to respond to the farmer's voice, like if it's angry or sad, or I guess happy or angry. So yeah, I don't know. The monkey one's the one that sticks out the most to me.
All right, so you all
I don't know how smart rats are. We had a small infestation, and I lined up 3 of my rat traps, one after the other, and I go up and look in the attic, and like all of them are filled. Like, oh boy, they see 2 other rats dead, and they're like, I think I'm gonna get this peanut butter. I think this one's gonna work for me. Snap,
Bob. Those aren't rats. Those are mice.
Mice, rats, yeah, whatever.
Bob, maybe they all died at the exact same time.
I discounted that possibility.
Wholesale.
Bob, I once caught 2 mice in a single trap.
Oh, twofer.
Nice.
Got a twofer. Yeah.
Holy crap.
Did
They're
you take a
running for it. It's mine.
All right. Let's start with number
Goats.
2. A recent study shows that goats are able to tell the difference between happy sounding and angry sounding human voices. You all think that one is science, and that one is science. That is correct. That was a recent study that showed that. And the way they did it was that they habituated the goats to one of the noises, either the happy noise or the angry noise, and then they flipped and see if the goats noticed, basically. And they did. They would attend more quickly and for longer to the change, in the what we call the valence, the emotional valence of the human voices. So that was their paradigm for can they tell the difference between those two things? And yeah, they're domesticated animals, and so it's not surprising that they would do that. Plus, goats themselves are very vocal, so they already have the wiring there, to hear and interpret.
They sound like babies.
Each other. Yeah, so it's not that much of a stretch. All right, let's go back to number 1. Most rats will stop pulling a lever to deliver a preferred treat if that lever also gives a fellow rat a small electric shock. Bob and Evan, you think this one is the fiction. Jay and Kara, you think this one is science. And this one is science.
Yeah, Jay.
Yeah.
Woot.
Whatever.
Good job.
I was right because I said if I was not right on this one, it was the other one.
Yeah.
I was right in what I said.
Covering your bets. So rats actually are, seem to have a pretty wide range of emotions, including behavior that seems to follow a construct of empathy. As Kara said, it is also a construct. And the researchers are quick to make a distinction between emotion and feeling, right? Feeling is a subjective experience. We have absolutely no idea what the rats are feeling. Emotion is a programmed response to a situation, right? That involves a behavior. So
it's like, how rats they laugh when you tickle them.
Mm-hmm.
And so, that's an emotion, maybe, like laughter, but you don't know if they're actually feeling joy or if it's just a reflex.
We don't know what they're feeling, but that's irrelevant to the research. So there's a lot of research in this area. This is not just like an isolated study. There's also a researcher who has been doing a series of studies in rats, and they found that a rat will also free a fellow rat from a cage, right? And they'll do that even if they don't get to subsequently interact with the rat. So they're trying to control for variables like, well, maybe he just wants to play with the rats. We're like, hey, come out here and play with me. It's like, nope, he'll free him just to free him. And
what a good boy.
But, Kara, only if they're the same color.
Racist rats.
Racist rats.
More specifically,
so bad about killing so many
more
of them.
specifically, only if they have been socialized to that breed of rat. So if they grew up,
interesting.
They grew up with that kind of rat. It's not just about color; it's also about just like
so it's like a kin thing.
The distinctive sort of breed of rat. If they were brought up alone, they won't free any rats, right? So yeah, they basically will free rats that they have been socialized to say that they're my group. They're whatever.
my kinship thing. That's really interesting.
Yeah,
there's a lot of interesting stuff in like evolution or evolutionary biology about like kinship evolution, not just the individual, but like the family unit or the the group.
Yeah, interesting research. And which means that capuchin monkeys are one of the few non-human animals to be shown to cry emotional tears. Is the fiction. Evan, you were right. Humans are the only animals that cry emotional tears. There's 3 kinds of tears, right? There's sort of the basal tears, or just the constant secretion to keep your eyes moist. Then there's reflexive tears, like you get something in your eye and it tears. And then there's emotionally triggered tears. And humans, we don't know why, but we're the only species that has emotionally triggered tears. We don't know evolutionarily why that happened, why it's never happened in any other species, but there it is. I thought it'd be a little bit too obvious if I said like a chimpanzee. That's why I went with the capuchin monkey. I thought the fact that they were so weird and specific might make it believable. I don't know.
I might have bought it more if it was a chimp.
Yeah, because you could
or
go
like
either
thinking
way.
about like Coco the gorilla or something. Like, I wonder what it would be like if there was an ape, like a chimp or a bonobo. I'd say bonobo. If a bonobo was raised exclusively around people who cried a lot. Could it learn to cry? Probably not.
I don't know.
It would imitate, but
I
maybe
think-
would it shed tears?
I don't know.
I think it's
Because
such
I don't know how much we evolved that as it's clearly a social response.
But it is an involuntary
It's
response.
hardwired, man.
Yeah.
It is involuntary, but it's, and you're right. Like, I don't like the word hardwired, but it's involuntary and somewhat reflexive. But we could have evolved for it to be that way because of social cues, like laughing or smiling.
Mm-hmm. Yeah, but babies smile even if they're blind. That's not.
Yeah, that's true. But
they don't have to see it.
Right. But I wonder how long, like, when did we start doing that? And did it continue throughout our lineage because we started doing it evolutionarily?
Yeah, those are always interesting questions. I know one of the ways that we try to get at it is to say, what are the things that are universal to all human cultures? And then we assume that it's plausible. Therefore, if like every human culture does it, it's probably something that was present, in our ancestors long before we divided up into, different cultures.
Yeah, it's probably like there's something genetic. And then the question becomes like, why is it in us and not a chimp? Or like, when did that division happen? Or I don't know. It's fascinating.
Right. I stayed away from pets because pretty much anything pets do, you would believe. You know what I mean? If I said whatever, if I said anything, and it's all true, it was really hard to find a negative. It was hard to find a definitive statement about an emotional ability that an animal doesn't have. You know what I mean? That's why I had crying was the only thing I could find to be the fiction. Because it's just,
and even with that, people will like claim up and down that they've seen animals cry emotional tears, but there's no good scientific evidence to back it up.
Yeah, it's pretty clear, I think, that they don't.
Yeah.
They're anthropomorphizing. They're just over-interpreting reflexive tears or something else. All right, Evan, give us a quote.
If you really want to rediscover wonder, you need to step outside of that tiny, terrified space of rightness and look around at each other and look out at the vastness and complexity and mystery of the universe and be able to say, wow, I don't know. Maybe I'm wrong. Catherine Schultz. She's a columnist with New Yorker magazine. She's also the author of the book, Being Wrong, Adventures in the Margin of Error.
Ooh, I want to read that.
Yeah.
Yes,
That
and that
sounds
line
good.
was the last line she delivered at a TED Talk back in 2017. No, that was the quote.
Yeah, I like it.
About being wrong. It's important.
All right, well, thank you all for joining me this week.
Thank you, Steve.
Saying that.
And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.